Right, guys, last lesson, the last video, we looked at how to calculate gradient, okay? And we also looked at gradients of vertical and horizontal line. Remember, horizontal, the gradient is 0. Vertical, the gradient is infinity or undefined. And we also looked at collinear points. Collinear points mean they're points on the same line, so their gradient will be the same. Fantastic. Now we're going to look at parallel and perpendicular lines. Okay? Right, so I've got two lines. Okay? Two lines. They are parallel, and James was already saying that they have the same gradient. The gradient must be the same because gradient is the steepness. So let's just quickly calculate it. Okay? The gradient here, okay, will be 2 minus 0 divided 1 minus 1. Watch out for that minus business. Okay? And we get 2 divided by 2, we get 1. Okay? Over here, delta y over delta x. Okay? 1 minus 0 divided by 2 minus 1. 1 over 1 equal 1. Fantastic. Okay? So if lines, let's call it A, B, C, D. If A, B parallel to C, D, or we can write down that MAB will be equal to MCD. Okay? Where, remember, we spoke last lesson that the M is really a gradient because it's the M from the YA, gradient on top of things. Okay. Right, I'll pause here and we're going to move on to perpendicular. Okay, so we're moving on to perpendicular lines. So I've got perpendicular lines, okay, A, B, and C, D. Okay, let's write that down. If A, B, perpendicular, that's how we write perpendicular. I don't know if you ever use that symbol, okay? You know what perpendicular means, right? Yeah. It's 90 degrees. Yeah. Okay, so what happens then? Obviously, we're not going to expect the gradients to be the same because they're definitely not parallel. But there is some kind of relationship between the gradients, and let's find out what it is. So we'll calculate the gradient of CD. So MCD, okay? Help me out here. MCD, the green one.
It'll be 5 minus 1
divided by
3 minus 5.
Minus 5.
So
6 over 8. The prettiest number. 3 over 4. Fantastic. Okay, so we'll put that aside for a minute. And then now, here, calculate MAB.
6 minus 2.
Okay, so just for the sake of it, I usually do right to left, but we can do left to right. It'll work if we're consistent. So let's just do that. Let's go with that. 6 minus 2 divided by
minus 4 minus 2.
And that is 8 minus 6, which is?
Negative.
Yes, I should have had a negative because this should be minus 6. I should have minus 4 over 3. Definitely not the same. One is positive, one is negative, as I'm sure you would have expected because one is going up or going down. But there is some kind of relationship between them.
They're the same numbers.
We've got similar numbers. I'll just pause here for a second. So what you guys just realized, just by me putting these numbers, right, that's the gradient of AB, that's the gradient of 3 over 4. If I put a multiplying sign between them, so if I multiply both the gradient, they cross cancel and they give you minus 1, because one of them is always going to be negative. Always one going to be going down, one will be going up. You can imagine, because they're perpendicular. So what do we find out? If AB perpendicular to CD, then MAB times MCD, the gradient of one times the gradient of the other will be equal to?
Negative 1.
Okay? So this way you can prove, if you ask, that lines are parallel or perpendicular. If you have two lines and they ask you to prove that they're parallel, you just find the gradient of each one of them and you show they're the same. If you are asked to prove that they're perpendicular, you find the gradient of each one of them, multiply by each other. If you get minus 1, you prove it. Okay?
So minus 1 always be your answer.
If they're perpendicular.
Will it always, no matter what?
No, we will have some time. Yeah, if they're perpendicular. If they're not perpendicular, it's not going to be minus. Okay? Well, I'm going to pause here, get you to do some work and see if there's anything worth recording.